Continuing with problem number 1, they would like for us to determine the overall order of the reaction. And so I'm looking here at our already determined rate law that we did in part A and B. The overall order is simply the sum of all the individual orders. So I'm looking at those exponents and adding together all of the orders. And so part C, the overall order would be 1 plus 2. And so this reaction is third order overall. Now for part D, determine the value of the rate constant baby K with proper units. And so since I have the rate law and I have experimental data, I now am going to plug in all of the information into the rate law. I just pick one experiment. It doesn't matter which one I pick. Hypothetically, it doesn't matter which one I pick. We should get the same answer for K, no matter which experiment, because K is a constant. And so it should be the same answer in every single experiment that we do. So let's just pick experiment number 1, and we're going to plug in the rate. We're going to plug in the molarity of each reactant and then solve for K. Alrighty, so we have plugged in all of our values into the rate law using data from experiment number 1. And now we're going to solve for K. K is equal to 1.5 times 10 to the negative 2. Now we always have to include units on the rate constant. This is a classic test question, exam question. We always ask you about what is the unit on K. And so remember, there's a very quick little shortcut, which I'll write here off to the side. All right, so our shortcut for determining the units on K, it's always going to be 1 divided by molarity with that capital M. And the exponent on molarity is going to be the overall order of the reaction minus 1. And then times the unit of time for that given reaction. And so since we've already determined that our reaction is third order overall, our units on RK for this reaction is going to be 1 over M. And so overall minus 1 will be 2 times the unit of time. This experiment is being run in minutes. And so there you have it. Our K is 1.5 times 10 to the negative 2, 1 over molar square times minutes.